Hello Internet, my name is Quinn and this is Blondihacks. It's the biggest day yet on the Pennsylvania A3 switcher locomotive build. I am going to powder coat the entire tender and do the lettering on it. This is going to be crazy. I have no idea if I'm going to be able to do this, if this is going to go well. There's so many ways this could go wrong. Let's find out. When last we left our tender, it looked like this. It's looking very tendery, but looks very much like a brass and copper model and not the real locomotive that we'd like it to at least somewhat resemble from, 50 yards or so. As I've said previously, this thing is going to get powder coated, so first step is to strip it all down into assemblies that can be powder coated as groups, which basically means any two pieces that never need to come apart again will be powder coated together for best possible result, but some stuff needs to come apart in order for the powder coat to get into nooks and crannies, or if those pieces need to come apart for maintenance. Now for the question so many of you have asked, which is how can you powder coat something that's been soft soldered because the cure point of powder coat is suspiciously close to the melting point of soft solder? A reasonable question. We're going to find out. I have a couple of secret weapons in case this is an issue. I've got two what they call low cure powder coats. These are low temperature melting powder coats. I've got one at 280 and one at 375. So we'll come back to these in a minute, but just know that these exist and may solve our problem. All the various accessories, however, have all been silver soldered, so there's no risk there. Only the water tank itself was soft soldered. So these will be done with my regular high temperature powder coat because the frame was done with that, so I need it all to match. I've already kind of committed to this high temperature powder coat. The job with each of these parts is to get them extremely clean with acetone and to figure out a way to hang them and ground them. For little parts like this lid, I'm relying on the hook being the ground as well. It's not ideal, but sometimes with a little intricate piece like this, there's kind of no other way to do it. But if your hook wire is really clean and has a good contact with the part, then you can get away with this. If you want to know more details here, I did an entire video on beginner powder coating, so go ahead and check that out if you want to get into this yourself. It's super fun and surprisingly easy. A thorough inspection and then into the oven with this first part. When you've got a lot of little parts to do, you can get a pretty good pipeline going because the 30-minute bake time is pretty comparable to the time required to clean and prep and ground the next part, apply the powder coat, and then shuffle everything down the pipeline. So to assist with this, I made myself a little cooling rack so I can move the currently cooling part onto there, free up the oven for the next part, and so on. First part of many turned out great, so I'm off to a really good start. The top is basically flawless as far as I can tell. On the underside, I did get some thinness. The coverage is not great, and that's probably down to my ground not being great on this part. If I'm being honest, I also just wasn't as thorough inspecting and powder coating the backside because I knew it wouldn't be visible. Where possible, this is my preferred method. I've got a ground plate bolted through the part in a way that won't show when the final part is done, because of course there's an area there that won't get powder coated. This gives me a place to clip the ground clip, and there's an extra hole on this tab that gives me a place for the mechanical hanger. This combination I find super effective and super foolproof. Here's that same method applied to the maintenance hatch. You can see that I've got a very secure mechanical connection that makes it easy and safe to transfer it into the oven, and I've got a very good ground thanks to the clip that goes directly on that plate. And none of this will interfere with the powder coat on the final part because none of the clips and attachment points are going to be visible when the final part is installed. Based on the questions I got, I realized I never actually explained what this maintenance hatch is for. Like, why is the water hatch sitting on this removable panel? This panel is removable so that you can install, access, and service the mechanical water pump that sits inside the tender. The pump is operable without removing this panel, but you do need to remove this panel in order to install the pump or if it ever needs repair. The idea is that you're never supposed to have to remove the water tank from the tender ever again. Once again, this part came out really, really nice. Powder coating is honestly pretty easy, and so it's pretty easy to feel like a boss doing it. It doesn't hide any flaws, as you can see, but it comes out really nice. Now this piece has some interesting issues on the back. You see this kind of area around the tab that didn't get good coverage. This is called a fisheye, and this happens when there's oil in the area that is underneath the powder coat. So if you don't get the area sufficiently clean, then when it's baked in the oven, that oil bubbles up underneath the powder coat and contaminates it, and this is the effect you get. In this case, there was probably some cutting oil in those threads or perhaps trapped between those two pieces because I didn't pull all these little pieces apart and try to clean all inside all the little threads and stuff. Perhaps I should have, and I should have taken this as a little bit of a warning, as you'll see, but I actually saw that in the moment and thought it was just poor coverage because, again, it was on the back and I hadn't inspected the back as closely. So more on fish eyes in a minute. Let's get into some of the trickier parts now. This is the floor pan. This is the single largest piece of the entire locomotive. Now, I am not going to powder coat the underside of it because it's just not necessary. You'll never be able to see it, and it's going to make this process a whole lot easier. I'm going to install the deflector on the end of the gun. The gun comes with this deflector, but they recommend removing it if you're doing small detailed parts, as I mostly am. However, this is a giant flat surface, and that's what the deflector is for, so on it goes. For grounding this, I've got a ground plate bolted through one of the bolt holes that will be inside the water tank when the tank is installed, so it shouldn't be visible. Then I run this wire straight up to the top of my little painting hood here, and that will allow me to spin the part around without that wire getting in my way, or more importantly, without that wire touching the powder coat while we do this. And away we go. As you can see, with a large flat surface, the powder coating process is less about spraying the powder on the part and more about creating a giant cloud of powder around the part, which is then attracted to it by the static charge. And this is why you do want to wear a respirator when powder coating, even though it's not like paint. You're not standing in a cloud of propellants and volatile organic compounds. However, you are standing in a cloud of plastic dust that is so fine that it's effectively a gas. And you don't want that stuff in your lungs either. And note that the draft fan in my paint booth is off right now. You do not want any kind of draft because that will mess up the ability of the powder to be attracted to the part. Don't get too close with the gun or it can arc. And what that does is it blasts a bit of powder off that area and you have to recoat it. Those standoffs that I'm using are silicone cones, or silicones perhaps? Those come in the Eastwood kit and they're intended for blocking off bolt holes, but they also work really great for this because the powder coat doesn't tend to stick to them and they can take the heat of the oven. A bright light once again to check for thin spots, and then into the oven we go. This is the nerve-wracking part because I knew that this part was about 3 millimeters smaller than my oven. I measured and this was the biggest oven I could get, but I knew it was going to be close. This is, however, the largest single component on the locomotive, so the fact that this floor pan fits means I will be able to powder coat the entire locomotive. And boy, that was close. If I had bumped that on the oven, it's not the end of the world. It just means you have to take it out again, blow off some of the powder, and recoat the area. Now with a big piece like this, I want to make sure it reaches temperature before I start the clock. With the little pieces, I just put them in for 30 minutes and they're fine. But with the big pieces, you got to let them come up to temperature, make sure they're at temperature, and then start the clock. 30 minutes later, out it comes. And again, try not to bump it on the way out. You can. The powder coat is reasonably durable at this stage, but until it's fully cooled, it can be a little bit soft. So best to not touch it, as strong as that temptation is, and let it cool down. While I was running through all the little parts, I passed the time by cleaning up the tender tank because my soft solder joints on this tank were frankly not great. There was a lot of extra bloppy solder and just places where this joint didn't look very nice. And this powder coat does not hide any sins. Honestly, if anything, it exaggerates them a little bit, possibly because I'm using a semi-gloss rather than a matte powder coat. But I knew it was going to pay off to make these joints look as good as possible before coating. So I put in the time here. I spent a good few hours just making all of those joints look absolutely as good as I could, making sure that all of the edges were clean and sharp. Everything looked nice. And of course, speaking of clean, boy oh boy does everything have to be clean, and boy oh boy did I put in the time cleaning. I went over every millimeter of this thing with acetone 7 or 8 times. I just kept going until the tissues had no dark spots on them at all from being rubbed over any part of the surfaces. Every edge, every corner, every nook has to be absolutely spotlessly clean and degreased. I did do a little bit of masking on the tender tank with Captain Tape. This is the only masking that I did. In general, I find it much easier to remove powder coat after the fact from places you don't want it than it is to prevent it from getting there in the first place. The masking is really fussy, but I knew that this inner flange surface here was going to be very difficult to remove powder coat from because of the shape of it and how tight it is in there. So I think it was worth taping off that area. All right, this is ready for powder coat. However, how do I know that when I open that oven, I'm not going to find a beautifully powder coated pile of scrap metal with a giant puddle of soft solder underneath it? That is the question. To answer that question, I'm going to do a test. I soft soldered a couple of pieces of scrap together, powder coated them with the high temperature powder coat, and let's bake this thing and see what happens. I've tried to create a worst case scenario, like a joint that's most likely to fail. So it's not a very good joint. I didn't clean it very well. I didn't apply the solder very well. And the lower piece is very heavy. So if this joint gets weak at all, then it should fall off of there or bend or deflect in some way. After a full 30 minutes in there at 400 degrees, just like the tank is going to be, I can check it, make sure. Yep, it's at 400 degrees. So that is where the tank is going to be. I think if that joint was going to fail, it would have by now. I mean, nothing moved, nothing drooped, nothing got crooked. I can whack it with a hammer. The joint is still perfectly strong. This piece is still at 400 degrees, mind you, even coming out of the oven like this. And I can't find any signs that that joint has gotten the least bit soft. A reasonable question then is, why did that work? Well, I think there's a couple of things working for us. First, I've cheated the cure temperature of this powder coat down a little bit. It's technically 425, but I've cheated it down to 400 because I know from experience that this Eastwood powder cures just fine at 400. The other thing is that solder, as I've talked about previously, does have a bit of a hysteresis to it. It does take more heat to melt it the second time than it does the first time. And finally, the solder that I happen to use is rated for potable water systems. And that particular kind of soft solder for residential plumbing happens to have a little bit higher melting point than other types of soft solder, such as electrical solder or non-potable plumbing solder. Now that wasn't some clever forethought, I just happened to use that because it's what I had. But I think all of those variables combined are really working in my favor. Now, all of that said, I am going to test these low cure powders just in case, because if one of them is a perfect match for the other powder coat that I've used, like on the frame of the tender, then I might use these just in case, because why take the chance, right? The first step when changing powders is you have to clean out the gun super thoroughly, which is a little annoying, but not too difficult. Basically, you use an air gun with low pressure. The book says to use less than 30 psi for this so you don't damage the gun, which my little trim compressor can handle, fortunately. And you blow out the intake tubes and the nozzle of the gun and just everywhere that the powder might be hiding, just so you're not mixing the old powder with the new. And all of these powders are black, which helps a lot. If you were switching from like black powder coat to white powder coat, you might have to be extremely fussy about this, or perhaps powder coat a dummy part first, just to really make sure you've got all the old powder out of the gun. I coated 2 samples, and let's compare them to the floor pan for appearance match. I've got the 280 on one piece and the 375 on the other. Now the 375 actually is a really beautiful finish. It's much smoother, there's less orange peel, and it coated really nicely. It's actually, I think, a nicer powder than the Eastwood stuff. If I had known how nice this stuff is, I might have done the whole tender in this, but I'm already committed to the Eastwood stuff. Now this stuff is quite a bit more matte. This powder did not come in a semi-gloss. The 375 is just not a close enough match. Now the 280 is an excellent match for the Eastwood stuff. However, if you look at it carefully, you can see the yellow of the brass coming through. So this stuff just didn't coat very well. I used the same method, same prep, same inspection process as for all my other parts, and I just really got a thin coating with this stuff. So I kind of don't trust it, honestly, because of that problem. With all those tests done, I decided to just go for it with the high temperature powder. I know how it behaves, I have strong evidence that the joints are going to be safe, and I know it's going to be a perfect match for the other parts that I've already done. I also remembered at this point that I actually have a Lazy Susan in my drawer, so that's going to make this a lot easier. I should have been using this before. Okay, here we go. Once again, I'm using the standoffs and the tray method because I don't need to powder coat anything on the underside of this tank, which is going to make life a whole lot easier. I don't have to hang it from anything, which would make it very difficult to get into the oven, because again, this tank is only slightly smaller than my oven. I'm running the ground wire to a section of that flange under the Captain tape where I don't want it to be powder coated anyway, and again running it straight up into the middle of my paint booth so that I can spin this part around without that wire touching the powder or getting in my way. And away we go. Even though there are some large surfaces here, I'm doing this with the deflector off of the gun because I do have a lot of tight spots as well underneath the verge board and around the base of the work light platform and so on. So I opted for no deflector just to make sure I can get into all the little nooks and crannies. I really took my time with the inspection light because next to a fisheye, the worst case scenario here would be a thin spot somewhere on the tank. My experience with powder coating is that powder coating a second time to fix thin spots doesn't tend to work that well. The finish is never quite as good when you do a recoat. So I really want to try and get this in one, making sure that my powder is nice and thick everywhere and that I can't see any of that yellow brass through the powder anywhere. This bright light inspection method is a tip from the Eastwood powder coating book, and it's a really good one. Under a bright light, if you've got thin spots in the powder, they really do show up when you do this. Well, I can't find anything wrong, so nothing to it but to bake it. This is not quite as tight a fit as the floor pan is, but it's still pretty tight, so definitely taking my time, being careful. The only thing on the locomotive larger than this water tank is the boiler, but the boiler won't be powder coated. Powder coating can't handle the temperatures involved in a boiler, so that will be painted with barbecue paint. All right, wish me luck. Once again, because this is a massive component, I made sure that it was fully up to temperature before I started the timer. If you just start the timer at 30 minutes, you might be shorting the part on cure time. And hey, I'm not going to lie to you and tell you that I didn't sit here staring at this thing like a hawk, waiting for a souffle to fall. Wait, do hawks make souffles? No, look, that metaphor got away from me, but I was watching it closely. You get it. All right, time's up. Either it worked or it didn't. Nothing we can do about it now. Let that cool off and let's see what it looks like. I would call this an 8 out of 10. It's not perfect. I got some fish eyes around the maintenance hatch area. We'll show you those in a minute, but the rest of it is pretty darn perfect, I have to say. Really, honestly, very pleased with that. I did get some slight fish eyeing right around those tiny number 0 bolts that attach the flange for the maintenance hatch on the underside. So there must have been a little bit of cutting oil in those threads that just bubbled up. It's not enough to really destroy the finish, but when the light hits it a certain way, as in this shot, you can see where the finish is different. You can see the fish eyeing. This is in general something that I just didn't anticipate. It didn't occur to me that those tiny little screws might have a little bit of cutting oil in the threads. I think in hindsight, what it could have maybe prevented that was baking the part by itself ahead of time to bubble up and bake out all of that oil before powder coating it. This is something that the book suggests for castings, for example, because castings often have oil baked into them or embedded in them, and baking the part by itself before powder coating can flush all of that oil out of those areas. But there's really not a lot I can do to fix this. If I try, it's going to make it worse. You can try to sand down those areas and then re-powder coat, but when you re-powder coat, it messes up the finish from the previous layer. I've tried that before on other parts and it really doesn't work very well, so I think I'm better off leaving it alone. This is a convenient excuse to talk about my approach to quality on this project. You can drive yourself crazy with little imperfections like that, and yeah, if you wanted, you could strip all of this powder coat off with acetone and try again until it was perfect. But if you do that, you're never going to finish your locomotive. I would rather finish this one, accept that it's not going to be perfect because it's my first one, and the next one is going to be much better. And in the meantime, I've built a locomotive that I can ride around on and have fun. Remember that perfect is the enemy of done. Don't let critics tell you that you can't do something because it isn't perfect or that it isn't good enough. All that matters is that you're having fun and your skills are improving. For all the little nuts and bolts, I decided to try this Birchwood Casey Brass Black. I don't want the hardware to stay brass because it's going to stand out like a sore thumb, but I don't want to try and paint or powder coat all this hardware because it's going to interfere with all the threads and the screw slots and so on. So we'll see if this stuff works. I gotta say, it actually worked pretty well. I got a really nice black coating on the head of that screw. It is a matte finish rather than gloss, so it's a little bit different than the powder coat, but it does the job of basically making the hardware disappear, and it was really quick and easy to run through all of the tiny screws and bolts and so on and give them that treatment. I did, of course, also have to clean the powder coat out of all the little threads, of which there are many, many on this locomotive. But again, in my experience, it's way easier to just chase all the threads than it is to try and keep the powder coat from getting into them. And powder coat doesn't like small, confined spaces, so it doesn't really get in any deeper than 1 or 2 threads anyway, so it only takes a second to clear the threads out. That's also why I removed the stairs for powder coating separately, even though they don't need to be removable. The area underneath each step was too tight of a space for powder coat, I feared. Small spaces like that create sort of an electrostatic bubble in powder coating where the particles can't get in underneath and into those little nooks and crannies. The low voltage setting on the dual voltage gun, I've learned, actually helps with that. Thanks to my patrons for that tip, but I didn't want to risk it with these stairs. Okay, it's time for livery. This is going to be exciting. Now, my sort of spiritual guide for this locomotive is 6269, which is a Canadian Pacific U3 locomotive, kind of a cousin of the A3. Canadian Pacific never actually ran A3 locomotives, so this locomotive that I'm building is fictional. The A3 was just too small for CPR. Even back then, Canadian freight was big. We have big yards and big freight, and we need big switchers. 6269 is still a good reference for me, though, because it's contemporary to the A3. This was built in 1912 in Montreal, and it has a similar slope-back tender, and because it's from the same period, the livery on it will be the same as CPR would have put on an A3 if they had one. As you can see, in these days, Canadian Pacific's livery was literally their name, all caps, in Times Roman. So that's good for me. That's an easy logo to create. I printed out a few samples and I experimented with kerning and spacing and font size to kind of get something that looked right to my eye and to figure out where on the tender side to put it. And this was about right, I think. To create this logo, I invested in a new tool. This, friends and Romans, is a Silhouette Portrait 4 vinyl cutter. Now, if you're not in the crafting, scrapbooking kind of space, you may not know about vinyl cutters. A vinyl cutter is basically you take a dot matrix printer from the 80s, you replace the print head with a drag knife, and you teach it G-code. These things are kind of a secret weapon because they do 65% of what a $7,000 laser cutter can do, but they cost like $100, maybe $200 for a mid-range model. These things are so cheap, and they can scan, and they can etch, and they can trace, and they can emboss, and they can cut all different materials. It's really quite surprising how much they will do. I priced out custom decals, and to order them was going to cost the same as this machine. So if you haven't looked at vinyl cutters yet, or you just thought they weren't for you because you don't sell throw pillows on Etsy, don't poo-poo them. These things are awesome. Now in my case, I'm using stencil paper, so I vinyl cut the logo, which I drew up in the Silhouette software. The software they give you is okay. For something more serious than this text, you'd probably want to use a real drawing program and then import it just to do the cutting. After that, we do a process called weeding, which is to pull all of the little negative space pieces out of the stencil. Basically, everywhere you want there to be paint, you pull that piece out of the stencil. They make special weeding tools for this. I don't know if those are worth the money. A hobby knife worked fine for me. Then to transfer this stencil onto the locomotive, we use something called transfer film or transfer paper. This is a slightly sticky film that you apply over top of your stencil. You want to burnish this down to make sure it's going to pick up all of the little pieces in the centers of the letters and so on. Again, you can buy special burnishing tools for this. I found the back of a craft knife or my scriber works just fine. You can tell when you've burnished sufficiently because the transfer film has an orange peel texture that goes away when the area is burnished. This stuff's all very clever. Smart people have figured all this out. Then it's time to remove the backer from the stencil paper. And again, to be clear, this is nothing that I'm inventing. This is a bog standard process for stenciling in all kinds of modeling and craft type of spaces. This is my first time doing it, but this is super standard. All the tools and procedures for this are well established. What's cool is that the transfer film is transparent and it has a grid on it so you can get your logo aligned with, in my case, I'm using the rivets as my alignment. And you don't have to get this in one. If you screw it up, you can just peel the stencil off, go cut another one, and try again. The stakes here are not that high. Then I burnish it again to make sure that the stencil is going to stay on the surface when we pull up the transfer film. This all works because the transfer film is slightly less sticky than the stencil paper, but slightly more sticky than the backer paper on the stencil paper. So, as I said, smart people figured all this out. When removing the transfer film, I did need to help the really small pieces a little bit, like the centers of the A's wanted to peel up a little bit, so just do this carefully. Make sure all of your pieces are staying down. And that's really it. That's the whole process. It's just that easy. The only thing left to do is mask off the rest of the area, and we will be ready to paint. I'm doing both sides at once because might as well. It's going to be a lot easier and quicker to just paint everything all at once. So after I did one side, I flipped it over, did the other side, and then when I'm done, the entire tender will be masked off except for those two logos. Just before paint, I'm going to use a trick that one of my patrons suggested to me, which is that you spray the stencil area with a clear coat of some sort. I happen to have this matte sealer from my Warhammer days left over, so I'm going to use this. And what this does is it seals the edges of the stencil to make sure you don't get any bleed underneath if any part of that stencil wasn't perfectly stuck down. This sealer will ensure that nothing can leak underneath it. I gave that sealer 30 minutes to dry, and then we are ready for paint. So now I do have the draft fan on because spray paint is nasty stuff, and away we go. Just spray paint all over the entire area until you have a nice even coat. Nothing to it. This part's easy. It was like half a day of prep work, but then the actual painting takes about 14 seconds. And amazingly, just as I finished the second side, this paint can decided to give up the ghost and exploded in my hand. And to be fair, this paint can is about 20 years old, but the paint in it is still fine. It's just the valves on these things that give up. Well, that was good timing. I finished both logos, and that'll be the end of that can. I let that sit for about 30 minutes. I wanted the paint to still be a little bit soft in order to hopefully peel away from the stencil cleanly. If the paint is fully hardened, I was afraid that the stencil would pull up some of the paint when I took it off. But I didn't want it to be too soft, of course, because then I would mess it up with my fingers, or the stencil might shift the paint around. So 30 minutes was hopefully about right. Real moment of truth now. Once again, trying to pull the stencil paper up very carefully and just keeping an eye on the lettering, making sure that nothing's getting left behind and that everything's pulling up cleanly. Definitely want to take your time on this step. I did lose a little bit of my lettering here. I lost a piece of the D and I lost about half of the serif on two of the other letters, but overall not bad. At this stage, you do have to weed again. You have to pull up the little centers of your stencils, which is tricky to do without messing up the paint, but again, take your time. The stencil paper comes off pretty easily, so it doesn't take much to just kind of poke it with a knife and pull it out of there. And the powder coat is tough, you're not going to hurt it. And we'll say the other side went perfectly, like not a single flaw on that side, so very excited about that. The first one I did, as I say, I lost a little piece of the D and a couple of the serifs, but we can touch that up with a brush later. Now, lest you think in some sort of super boss move mic drop, I just did that all in one go. No, I did a test piece with every step in this process. The powder coating, the matte sealing, the stencils, everything, to make sure that it was all going to behave the way I thought it was. And doing that test piece, I learned a lot. I made a lot of mistakes. I figured out all the settings for the vinyl cutter and etc. So well worth doing some practice pieces. The last thing I'm going to do is just try to make sure that this thing is watertight. Some of my soft solder joints, probably not great. So I've got an old tube of Honda Bond that I need to use up anyway. This is a really good quality RTV. I'm going to smear a bunch of this on the insides of all my joints just to make sure that nothing leaks. And yeah, I know this looks like it was applied by Cleo, the donkey who got into the cider barrel again, but no one's ever going to see this, so the old wet finger method for silicone works just fine for functionality here, if not appearance. To seal the bottom of this tank to the floor pan, Kozo actually says to just goop the whole thing up with silicone and stick it down and call it a day. I decided to try and make a gasket so that I can remove this water tank if I ever need to. This didn't actually work out. Turns out my flange on the bottom of that tank is not as flat as I'd hoped it was. When I put it all together, I could see daylight under a couple of spots on that gasket, so it was definitely not going to seal. If you've been watching this series, you may recall that I flattened that flange on the belt sander, which seemed like it worked okay, but turns out it didn't. I probably should have machined the flange instead. I've ordered some thicker and softer gasket materials to try and get that sealed up, but if not, I can do what Kozo says and just goop the whole thing up with silicone, call it a day, and then rely on the maintenance hatch for access to the inside of the tank. I put all of the handrails back on, and then finally I will touch up that lettering with an artist brush and a little bit of white paint. Once again, a decade of my misspent youth in Warhammer has trained me for this moment. There it is, one Canadian Pacific A3 tender. Done. Done. It's super done. Well, it's mostly done. We do still have to fix that water sealing issue on the bottom, and we need to build the water pump that goes inside this thing. However, that's into the mechanical stuff now, and that's what I'm really excited about. From here on out, it's all valves and lubricators and pistons and cool stuff that moves and functions and makes noises and all the stuff that I love. All of the tedious sheet metal work and structural stuff is done. I can't tell you how thrilled I am to be at this point in the project. Thank you so much for watching. Without your support, both emotional and financial, I would not have made it this far. Thank you so much to all those who support me here on Patreon and through PayPal over on my website and here on YouTube through Super Thanks. All of it adds up to where I can do something like this project. Thank you for watching, and I will see you next time.